So we're getting to revision 21, and this is sets and Venn diagrams. Okay, so it's the language you have to learn here. Okay, this little symbol here means a universal set. It means nothing else can be in there. That's everything, the whole group. And so Venn diagrams are more to do with space and allocating things into the right space. So here we've got this labelled A and this B. And the universal set, now this is really important, okay, you get this right. These are all the numbers. It seems all the numbers up to 1 to 16. I'm actually going to write them out because you can then tick off. There we go. That's all the set. And then it says in A, the group that are A are those that are multiples of 3. So in there, it's all multiples of 3. But you can only choose from this set here, okay, because that's a universal set. It's the only set you're allowed to choose from. And B are multiples of 5. So you can only choose those ones. And then it says one of the numbers is selected at random. All right, okay, what's the property of A and B? That is being in A and being in B. So it has to be in both combinations, which you'll find is occupied by that area there. So what I need to do is I need to fill in this. It says complete it. So the first thing I'm going to do is find out those that are in both multiples of 3 and 5. Okay, so I know the multiples of 3 and 5 are going to be clearly 15. 15's in that, and I don't see any other number that is a multiple. Now multiples of 3, I'm going to write them out. 3, 6, 9, 12, that 15, there's no 18, so that's multiples of 3. Multiples of 5, 5, 10, 15, so there's my 15. So in B it's going to be 5 and 10, and in A I'm going to have 3, 6, 9 and 12, and my 15 is there. And then everything else gets squeezed in where you can around the edges here, and you need to make sure that you put in everything else and not double it. So don't put the 9 that I was just about to put in. Okay, there's my 12, 13, oh 6 I've included twice, so grab that out of the way. 14, put that, it doesn't really matter where you put it. And 16, as long as it's not in the circle. And as we said, the question then says what's the probability of being in A and B, and there's only one in A or B out of all 16. So that's how you'd write that one, 1 out of 16. Then this question says, okay, they've got ice cream, that's my cat, and you've got a number of people that like ice cream, and you've got a number of people that like custard. Okay, so that's your ice cream, that's your custard, and you've got the universal set, so this means that everyone investigated was here. You've got 13 outside, that means that there are people that don't like ice cream or custard or haven't asked for it. You've got 9 in the middle, that is for both. You've got 51 here, which is ice cream but not custard, and 34 custard but not ice cream. So with probability, the language is a thing that stumbles for people, and that you've got to just get used to that language. At a wedding, the guests have ice cream or custard with their dessert. The Venn diagram shows the information about the choices the guests made. How many guests had custard? Well, that's just 34 plus the 9, because you've got to include those. They also had it, the greedy little blighters. So that is 43. How many guests had ice cream and custard? Ice cream and custard is just 9. So they just had 9. And how many guests went to the wedding? Well, that's all of these people here. So it's 50 plus the 9 is 60, plus the 34 is 94, plus the 13 is 107. So there's 107 people went to the party. And I'm just going to use my calculator because it's late in the day and I'm now tired. So I just don't want to make sure I make silly mistakes. 107. Boom. There you go. So the next set of questions are quite complicated, so what I'm going to do is make that another video for you.